Welcome back for part 2, multiplying and dividing. So it's basically what we just did with simplifying, but times 2, because we're going to have 2 fractions instead of 1. Yay! The real quick, remember when you divide by a fraction, you multiply by the reciprocal. When that occurs, when you've got divide by a fraction, do this first. Knee-jerk reaction is, I don't want to see a division sign there anymore. That way, every problem you're working is actually a multiplication problem. It's just whether you have that first extra step or not. So this is the point where the book talks about the restriction agreement. Yes, nice and ooh. So now they just make the assumption that the values are restricted. Don't put in bad numbers. Okay, we're good. Especially like on this first one, like x can't be 0. And if x is 0, y can't be 0. But y could be 0 if x was not 0. That's the other reason why they're checking out restricted values. It starts to get confusing. You will not graph something like this, though. 2 variables, we're not graphing that. We're only going to graph in one variable, just x's. So most of our work will be in one, but sometimes they're like, let's be crazy. All right. Let's be crazy. Oh, wait, I already am. Aren't we all a little bit mad? All right. So it's multiplication. Don't have to worry about the flipping the fraction thing. So the next thing you do is factor everything. If it can be factored, factor it. If you're not sure, try. So our first one, the 7x minus 7y, they have 7s. So we have an x minus y there. Now on the bottom, I have that weird x squared minus 2xy's plus y squared. I am hoping that looks slightly familiar, that 1 with the 2 and the 1 pattern. That's our perfect square. We're still going to write it side by side, plus x squared. It's going to be x and x, y squared, going to be y and y. And the only way to get positive y squared and negative 2xy is if they're both negative. So would you look at that? There's the x minus y on top and on the bottom. Woohoo! You could even start canceling if you wanted. I prefer to factor everything and then look, just to be sure. All right, times. Now our other one, x squared minus xy, they have an x. Times x minus y over. Now 21x, you can't do much with it, so I'm just going to write it. Now the fun part. I love this. It's like cleaning without having to get out of my chair. So I have an x minus y and x minus y. Those are gone. I'm going to use multiple colors. This x minus y with this x minus y. Gone. So it doesn't have to be in the same fraction as long as one's on top and one's on the bottom. We can cancel. I mean, technically, the middle step here is you multiply the fractions, which means you multiply the tops, so you smush it all together. You multiply the bottoms, smush it all together, and then you do this canceling step. I always hated writing that step, though, because it was like, I could just erase the dot and make the bar longer. There, they're together. So I just cancel from here. We also have a single x, and down here, this is 21 times x. So those can be canceled. Sometimes we will have single things like that. And one more. So the only thing left right now is 7 over 21, which hopefully in your brain, you're like, wait, doesn't 7 go into the 21? It does. So we're going to divide, cancel the 7, and 7 goes into 21 3 times. Now the I'm tired and I've been doing too much work, 3, that's my answer. No, 3 is not the answer. 3 is part of the answer, but it's on the bottom. Everything on top got canceled. Remember earlier I was saying this is multiplication division. So if everything divides out, thing divided by same thing is always a 1. So if you find everything gone, you put a 1 as a placeholder. You can also think of it as I divided the top by 7, I divided the bottom by 7. 7 divided by 7 on top is 1. And 21 divided by 7 on the bottom is 3. All that work to get 1/3. At least it's easy to type. Now we're going to do one division problem. Knee-jerk reaction before you start factoring anything. And it sounds funny, but you'll be tempted. Change the division out first so you don't forget. Because these problems are often set up so if you do forget, you'll still get like one little thing to cancel. And you'll be like, yeah, I did the thing. And so always your first step. Knee-jerk. I don't want to see division. Y cubed minus 27. There's that promised cube. 9 minus y squared. Weird. Changing it to times. Flip it, so the y squared plus 8y plus 15 is now on top. And the 5y squared plus 15y's plus 45. All right. So we have 4 different pieces here that we need to factor. Each of these will factor down. The way they factor is going to be a little weird. Okay. So what I usually do on this is I'll actually like take each one to the side if I don't see how it factors right away and play with it. And then I'll come back and put the results in my like next step. So it's like scratch work and actual work. We have very crazy cats. All right. So down here. So that's going to be where I fill in stuff. All right, now our first one here, I'm going to take that y cubed minus 27. And what I'm going to do is kind of leave myself a little workspace here. Like that's where my formal work is. And then over here, we're going to do scratch work. Here, let me, just so we're sure. So a cube, y cubed minus 27. So I did lecture this. This was square, opposite pair plus square. So the first one is the cubes that you see without the cubes. So instead of y cubed, it's y. Keep the sign, minus. 27 is 3 cubed. So our first part is y minus 3, which means we're going to expect to see a y minus 3 somewhere else. This other part, though, is probably just going to be stuck in our answer. So we get the square of y, opposite, so this is a plus. The pair would be 3 times y, plus the square of 3 would be 9. Remember, that second quadratic never factors. I could shove it in the quadratic formula and get an ugly mess, but it doesn't factor. So now we are going to take that and move it over there. Poof! Love computers. All right. Next. Just not the best at getting it to change after I do that. I hate my computer. Yay, finally I got it to work. All right. We're going to take 9 minus y squared, pull it over here. 9 minus y squared. That's backwards. And because I'm going to be canceling stuff, I don't want to deal with this backwards. So the first thing is it's subtraction. If it was addition, I could just flip it. But if it was addition, it wouldn't factor. So I'm going to factor out that -1. That would be the same as -1 times y squared minus 9. There's that difference of squares. I could have factored it before, but remember that y minus 3 we've got. I'd rather see this as y minus 3, y plus 3. And it just happens to have a -1. Now, Alex might explain this as y minus 3 and 3 minus y cancel to become a -1. And that's true, but I hate, it feels like hand waving to me. It's a no. So, and to not do that madness anymore, we're going to write it. All right. Now, a little more interesting. Y squared plus 8y plus 15. I'm saying it so I remember when I write it. All right. So it's a y squared. There's no number in front, so that means for sure we know it's going to be a y and a y. And there's not a lot of choices here. 1 and 15, way too big because everything's positive, so these are for sure pluses. So 5 and 3. 5 plus 3 is 8. 5 times 3 is 15. There we go. Y plus 5, y plus 3. Now, if you're getting more comfortable, if you've done a lot of factoring, you know, you might feel confident just going from the problem we wrote here to just starting to write the factoring down without having to do the scratch work, and that's totally fine. You don't have to do this scratch work. I've just found better to explain too much than not enough, because it is very annoying to listen to somebody not explain enough or explain poorly. All right, so 5y squared. And that's not to say I always explain perfectly, but I do try very hard to explain nicely. So 5y squared plus 15y plus 45. Hopefully you're looking at all those numbers and going 5, 5, 5. That's a lot of 5s. It is. And we're going to factor it out. So now we have y squared plus 3y's plus 15. No, not 15. Plus 9. Wait a second. That's familiar. Yep, there it is. That's our ugly quadratic from the cubic, which does not factor. So all we do is pull out the 5, cha-ching, take it over. We're going to get a lot of canceling here. Normally, they don't bother writing it, so this ugly thing will cancel. It's just part of the answer. Cool. All right. Purple highlighter for the canceling. Here we go, the fun step. Y minus 3, y minus 3. Ugly quadratic, yay! Y plus 3, y plus 3, whoop. All right, that's all she wrote. So I got a negative, a y plus 5 over 5. So that's what we're gonna write, negative y plus 5 over 5. You can type it like this. There's a catch. If you're not paying attention, the minus sign can end up on top, and this is not the same as negative y plus 5 over 5, like that. You might be saying, hey, Liz, you moved that negative before. True, but if we are going to move it, then we need to see it with parentheses. So it is the same as the negative onto y plus 5, or you change the sign of both of them. And this is like the #1 mistake people make when they're doing their maths, even the calculus students, even the grad students. We all make this mistake every once in a while. So just be on the lookout for that. That minus, when it's attached to a fraction, if you're going to move it to the top, it has to apply to everything on top. If you're going to move it to the bottom, it has to apply to everything on the bottom. So safe math, use your parentheses. Next video is going to be adding and subtracting, which does mean common denominators, but they're going to look weird. All right, but that's for the next video.